In this tutorial, we will give a brief overview of the expression analysis performed by IBD. The click and go option means that we have already run the analysis. However, if you want to rerun it, then you have two choices, parametric or non-parametric tests. As quantile normalization has already log transformed the data and the data is neither nominal or ordinal, we will proceed with running a parametric test again. Over here, we have options to run lemma or unpaired or paired t-test. We will choose lemma. Whilst performing the analysis, we can choose amongst different methods of false discovery rates as well as the level of fold change we wish to observe in our experimental data sets. The annotation selection tool allows us to insert or remove additional probe-related information to the final comparison list. Once the analysis has been run, the data will be summarized in lemma analysis table and a comparison results table. IBD will also generate high-end visualizations which include profile plots, which are used to display gene expression values or their transformations on all arrays for a given gene, or a summary of the gene's expression values, such as the mean in different groups or classes of arrays. Bin fold change bar chart, which is used for comparing the number of unique probes with regards to fold change. The number of probes are shown on the y-axis, while the fold change values are binned based on the range of the data. Volcano plots are useful for visualizing differentially expressed genes that have already been detected using a statistical test. They are a plot of the log fold change on the x-axis, and often the y-axis is the negative log 10 of the p-value, where the p-value comes from the statistical test. This means that those genes that are located closer to the upper corners of the plot are those with a greater and more significant fold change. The volcano plot allows for the selection of genes directly on the plot and is a useful tool when it comes to creating gene lists. Once you've selected the level of fold change you're interested in, the genes of interest will be highlighted as all the visualizations are synchronized. You can now go and create gene lists based on this selection and name them as you wish. The data can also be exported out with relative ease as a text file. The comparison results table is presented in the Analysis Summary tab. However, if you wish to observe it next to your visualizations, then you can easily add a new table in this tab and choose the table you wish to see from the table matrix. It is also very easy to create heat maps based on your comparison data, and the labels can be added by right-clicking on the axis. This Analysis Summary tab also presents filtered lists based on the fold change criteria we have set. Just like the data tables, the visualizations can be easily exported to various formats. Please refer to pages 187 to 237 in our manual for a further explanation of differential expression analysis in IBD. For further information and tutorials, please visit www.integromics.com